All right, everybody, one more set of tests regarding asymptotes. This time we want to be able to find a horizontal asymptote. We've already established that we find vertical asymptotes by setting our denominator in our reduced polynomial equal to 0. When we're looking for a horizontal asymptote, the test is slightly different. So let me describe this. It says let f of x equal a sub n x to the n plus a sub n minus 1 x to the n minus 1, etc. and b sub m times x to the m plus b sub m minus 1 m minus 1 power in the denominator. In other words, we have in the numerator a polynomial with degree n, whatever that degree is. In our denominator, we have a polynomial of degree m. Okay, they could possibly be different, they could possibly be the same. It doesn't matter. All we're looking for is the degree of those polynomials in order to conduct this test. So what's the test say? It says if the degree of the numerator is less than the degree of the denominator, then our horizontal asymptote will be the line y equals 0. Yes, always. So for example, let's look at g of x. G of x is the kind of polynomial function, as we established in the last video, in which the vertical asymptote doesn't exist. So we would say that there is none. We find the vertical asymptote, remember, by setting the denominator equal to 0 and seeing if there's any real numbers that satisfy that equation, and in this case, there is no real solution. Right? That's why we can say there's no vertical asymptote. But what about the horizontal asymptote? Well, for the horizontal asymptote, we look at the degrees of the numerator. The degree of the numerator is equal to 1, right? 2x plus 3 is a first degree polynomial. And we look at the degree of the denominator. In this case, that's 2. Since the degree of the numerator is less than the degree of the denominator, we conclude that y equals 0 must be our horizontal asymptote. That's supposed to say horizontal. Woof. Boy. There we go. You get the picture. Okay, so this is our horizontal asymptote. It has to be the form of the line y equals something, if it exists. All right, how about this one? Well, in this case, it says, the next piece of the test says, if the degree of the numerator is equal to the degree of the denominator, then y equals a sub n over b sub m. What? Well, a sub n is the leading coefficient of your numerator. B sub m is the leading coefficient of the denominator. So here's what this one says. Our vertical asymptote is always found at whatever number makes the denominator equal to 0. In this case, that's x equals 0. For our horizontal asymptote, we'll note that the degree of the numerator is 2, and so is the degree of the denominator. Since the two are equal to each other, we conclude that y will equal the leading coefficient of the numerator over the leading coefficient of the denominator, so we take the leading coefficient of the numerator over the leading coefficient of the denominator, and that's going to be our horizontal asymptote of that line, and so this is our horizontal asymptote. And actually, if we go back a few slides, we can see that I'd used this example previously about horizontal asymptotes. The degree of both the numerator and denominator was equal to 1, and the leading coefficient was equal to 1, so the line y equals 1 is another example of where that horizontal asymptote lies. Okay, let's look at our last one. The vertical asymptote in h of x has to be at x equals 2. There are no common factors of the numerator and denominator. As to the horizontal asymptote, if we're interested in finding the horizontal asymptote, we look at the degrees. If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. The degree of the numerator in this case is 3, and the degree of the denominator in this case is equal to 1. And so we're going to say that there is no horizontal asymptote at all. That's supposed to say horizontal. Trust me, it does. There is no horizontal asymptote in this case. There might be some other features, but we'll talk about them later. But in this case, we're going to say just no horizontal asymptote at all. All right, more to come in our next videos.